So our goal today is to deal with a couple of little details. One is, what if you have more than one unit to get rid of? The other is, what if it's not metric? Okay. And if it's not metric, we're going to run into a different set of problems. And the different set of problems we're going to run into if it's not metric is, how do I do sig figs from inches to meters? Okay. So, first thing we want to do is talk about how sig figs are affected by those conversion factors. Okay. So, if you're in the same system, we've been doing all metric system, we haven't really had to worry about sig figs. However many sig figs I started with, that's how many I was going to end with, because they were all definitions in between. Okay. So far, they were all in the same system. We went from meters to kilometers, liters to milliliters, but they were all metric pieces. So every one of our conversion factors was exact. They were definitions. Okay. And definitions has unlimited sig figs. So my smallest sig figs were going to be the number I started with. However many I started with, that's everything else is going to be unlimited sig figs. So that's how many I'm going to end with. Okay. But what happens if you want to go between feet and meters? Okay. Well, to go between feet and meters, you actually have to take a stick that's lined up that's measured in meters and put it next to a stick that's measured in feet. That's the only way to go. They're not defined on each other. They don't have the same definition, so the only way to go between them is to measure them. So going between systems is always a measurement. And since it's the measurement, it's got sig figs, not unlimited. So we're not talking about how many sig figs there's going to be in my answer. We're going to talk about how many sig figs there's going to be in the conversion factor. Just the parentheses part. Okay. And the bizarre part about this is it says as many as the most sig figs. We're used to doing the least sig figs. What is this most sig figs? Well, here's an example. 1 inch is 2.54 centimeters. Why? Why is 1 inch 2.54 centimeters? Well, because they took a ruler that was measured in inches and put it next to one that was measured in centimeters. And it was about 2.54 centimeters to equal an inch. They took rulers and put them next to each other. Excuse me. Now, one of the conversion factors I can make is this. When you look at this conversion factor in terms of significant figures, you're tempted to say the 1 inch has 1 sig fig and the 2.54 has 3 sig figs. That's what you're tempted to say. But let's think about what that means. If you say 1 inch has 1 sig fig, that means the marks on your ruler, the first mark on your ruler is a 10. And 1 inch would be about right here. So something about right there would be 2.54 centimeters. That doesn't sound right. There's a whole range for that 1 inch. That means it's someplace between half an inch and an inch and a half. Is something someplace between half an inch and an inch and a half going to be 2.54 centimeters? I have to know the 1 inch as well as I know the 2.54. I got to know exactly where the 1 inch is. So I have to know the 1 inch as well as I know the 2.54. Otherwise, I couldn't make the measurement. Okay. So we ignore that 1 inch part. We say that this whole conversion factor has 3 sig figs. The whole conversion factor, not the number inside, but the whole conversion factor. So the conversion factors, you look at the conversion factor and say, how many sig figs does that conversion factor have? That conversion factor has 3 sig figs because there's two numbers, a 1 and a 2.54, and I picked the most in that conversion factor. Then when I multiply it, I do the least in the problem. So I count the sig figs and the conversion factors, and then I go back and do the least number in the problem because that's the rule for multiplication and division. Let's see what it looks like when it's not metric and we got to worry about it. So, a race, it's got a 10K race. It's 10 kilometers long. How far is that in miles? Okay, and I'll give you a couple of little equivalent statements, two things that are equal to each other to make our lives a little easier. That a mile is 1,760 yards, and that a meter is 1.094 yards. Okay, so we start this like we started all our metric ones, by writing down what they gave me, the 10 kilometers. Okay. And then, oops, make my conversion factor. What unit do I want to get rid of? Kilometers. Where does it have to go so it'll cancel out? On the bottom. What can I turn kilometers into? Well, I can turn it into a bunch of things. I probably should make my plan so that I can end up in miles, right? I'm going to make a plan. So I need to get to miles. The way I can get to miles is from yards. The way I can get from yards is from meters. And meters I can get from kilometers. So I'm going to be able to get from kilometers to miles eventually. So you start from both ends and work to the middle and see where they're going to run into each other. The units tell you how to set up the problem. Okay? So kilometers, in order to make my progress, I need to turn kilometers into meters. Okay? Commonly missed one on the homework. Which one's bigger? Kilometers are bigger. Kilometer gets the 1, the meter gets the 1,000. Now, what unit do you want to get rid of? Meters. Where's it got to go? Because you got to have one on top, one on the bottom for it to cancel out. What can I turn meters into? I turn meters into yards. I just copy the numbers. The number in front of yard is 1.094. The number in front of meter is 1. Meters are gone. Now, what unit do I want to get rid of? Yards. Where's it got to go? Bottom. What can I turn yards into? I turn yards into miles. Miles, MI. Don't just put M because you already use that because that's meters. Okay, and it says 1 mile is 1,760 yards. Okay, so start off by pushing the 10 times 1,000 times 1.094, and the 1760s on the bottom, so I push divided by 1760. And that equals, my calculator says, 6.2159 repeating. The 90 repeats. Okay. How many of those do I get to write down? Well, I got to figure out sig figs. So, 10.0 kilometers. How many sig figs? There's 3 sig figs in 10.0. The 0 is after the decimal point, so it counts, and the other 0 is in between, so it counts. Okay. Meter, kilometer, same system or different system? Same system, and same system always has unlimited sig figs. Why is there 1,000 meters in a kilometer? Because a kilometer is defined as 1,000 meters. It's a definition. Okay. Next conversion factor, meters and yards, same system or different system? Different system. So I got to look at that conversion factor and take the most in there. So if I know that top one to 4 sig figs, I have to at least know the bottom one that far. So that would be 4 sig figs in that conversion factor. Miles and yards, same system or different system? By system, we mean all the English pieces. Another system would be all the metric pieces. Another system would be all the Elvish pieces. Okay? So same system, so that would be unlimited. So when I'm counting my multiplication sig figs, I've got 3, unlimited, 4, and unlimited. Which of those numbers is smallest? 3. So I'm going to have 3 sig figs. The third sig fig is the 1. Behind the 1, there's a 9. So 6.22. And the units are miles. Hugely different math-wise than what you were doing with metric system? It's different because we added a third one. We've never done 3 before. Okay. But it's actually easier. Because if you walk up to me in the middle of a test and ask me how many yards there are, or how many feet there are in a yard, I'll give you 1 of 2 answers. I'll either say 3, or I'll say you have enough information to solve the problem without knowing that. Because there's going to be some way to get there. Okay. If you ask me how many meters there are in a kilometer, I'll say you should know that and we'll move on. I don't care if you know the English system. I care if you know the metric system. This is easy because you just had to copy numbers. You didn't have to remember them. Right? So, driving across the country this summer, as you're coming across Kansas, you are really happy to see Pikes Peak. Okay? Pikes Peak is Colorado, right at where the plains meet the Rockies. And it's 14,110 feet above sea level. What is that in meters? So you see it in the distance, say, oh, there's Pikes Peak. And then you drive for 2 hours and you're still not there. Because the ground is flat before you get there. So, 14,110 feet. Okay, and I want my final answer to be in meters. How can I get from feet to meters? Well, let's work it backwards. Meters, I can get from yards. Right? So I'll be able, if I get to yards, I'll be able to get to meters. Can I get to yards? Can I turn feet into yards? Yeah. So that's my plan. I'm going to turn feet into yards. So, and then I'll be able to turn yards into meters. So what unit do I want to get rid of? Feet. Where's it got to go? On the bottom. What can I turn feet into? Yards. And 1 yard is 3 feet. So I cancel out the feet, cut the feet out from underneath you, and you fall down. Now what unit do I want to get rid of? Yards. Where's it got to go? On the bottom. What can I turn yards into? Meters. I don't have to remember. I don't remember which is bigger or smaller here because they said right there, 1 meter is 1.094 yards. And I get 14,110 feet divided by 3 divided by 1.094 equals, my calculator gives me 4,299.2078. More numbers than I can justify. I think that's what the book said, right? Your calculator gives you more numbers than you can justify based on the original measurements. Okay. So, sig fig wise, 14,110 feet. How many sig figs? 4. Yards and feet, same system or different system? Same system, so same system is unlimited. Meters and yards, same system or different systems? Different, so my number of sig figs here is, the 1.094 has 4 sig figs. So sig figs wise, I've got 4 unlimited and 4, which is the smallest number? 4, so I should have 4 sig figs in my answer. That's 4,299 meters. See what I meant by the conversion factor has sig figs? Because the conversion factor is really 1. We're trying to decide how many sig figs does that 1 have. That's what we're trying to decide. How many sig figs does that 1 have? Because we're really multiplying by 1. Okay. The speed limit is 65 miles an hour. What is that in meters per second? And I got those same 2 factoids that we've had for the last couple ones. You see why I call it multiple units, miles per hour and meters per second. I want to turn miles per hour into meters per second. I cannot turn miles per hour into meters per second. But I can turn miles into meters, and I can turn hours into seconds. Those I can do. So that's what I do. I don't turn miles per hour into meters per second. First I change the miles into meters, then I change the hours into seconds with conversion factors. And that's going to have us do something different, something we've never done before. Okay. So first thing I do is I write my 65, and I write the units as vertically so that I can see a top and a bottom. Get rid of the slash, turn it so it's lined up vertically, so you can think top and bottom, because that's kind of a key concept to what we're doing, top and bottom. What unit do you want to get rid of? I can get rid of miles, or I can get rid of hours. I can't get rid of both. It doesn't matter which one I pick. I already picked because I already typed it out, but it really doesn't matter which one I pick. So I'm going to get rid of miles first. If I want to get rid of miles, where does it have to go? On the bottom. What can I turn miles into? Yards. I turn miles into yards. And I copy the numbers off my equivalent statement. 1,760 yards is 1 mile. That makes it a good conversion factor. And my miles have canceled out. Now, what unit do I want to get rid of? Yards. Where's it got to go? On the bottom. What can I turn yards into that will get me closer to my answer? Meters. I can turn yards into meters. See how this is just like the problems we've been doing. Absolutely nothing different. Because it's on top, it goes on the bottom to cancel out, so it's just like we've been doing. Now for the tricky part. What unit do I want to get rid of? Hours. Where does it have to go so it'll cancel out? It has to go on top to cancel out this time. I have to put hours up here. Because I already got hours on the bottom. If I put hours on the bottom again, that'd be hours squared on the bottom. I don't want hours squared. I need hours on top if they're going to cancel out. That's the new part. Because up to this point, you guys have been wondering, why the heck is he asking where's it got to go? It always goes on the bottom. No, it doesn't. It doesn't always go on the bottom. Sometimes it goes on the top. So if what you want to get rid of is on the bottom, to make it cancel out, you got to put it on top. Otherwise, it won't cancel. Okay. And hours I'll be able to turn into. Okay. People say seconds, and then if you say seconds, write the number down, because I bet you about half of you will write the wrong number. Okay, because lots of people will write down that 1 hour is 60 seconds. Okay, 1 hour is not 60 seconds. Otherwise, this class would be a lot shorter. Okay, So everybody understand why the hours had to go on top? I mean, and then now I can get rid of minutes. Where does minutes have to go to cancel out? At the top again. And I can turn that into seconds. And I'm pushing buttons. Yeah, you can. But I'm telling you that people who do that oftentimes write 60 seconds. I have graded lots of papers. And you can see it happening, can't you? I've made the mistake. No, several times. Because I've had lots of years of doing these. Okay. And my calculator says 29.04732886. Way too many numbers to justify. So I got to think sig figs. All right. And let's start at the other end. In 1 minute, 60 seconds. Same system or different system? Same. So that's unlimited. 1 minute, 1 hour, 60 minutes. Same system or different? Same. Unlimited. Meters and yards. Same or different? Different. So how many sig figs there? 4. Okay. 1,760 yards is 1 mile. Same or different? Same. So it's unlimited. How many sig figs in 65 miles an hour? Read the first sentence again and answer the question. How did they get 65 miles an hour? Did they measure it? No, a group of people up in Sacramento voted. We are going to make the speed limit 65 miles an hour. They never measured anything. They just voted, right? It's not measured. It's a definition. 65 miles an hour in this case is a definition. If it says you're traveling 65 miles an hour, that's 2 sig figs. But this is not talking about you traveling. This is talking about a piece of paper says the rule says 65. So in this case, the 65 has unlimited sig figs. You got to think about where the numbers come from. Can't just, the math class numbers come from the air. Here they come from someplace. Either they're a measurement or they're a definition, or you counted them. That's the 3 places you can get numbers. Okay? So with that, what's my smallest number of sig figs? 4. Right? Unlimited, unlimited, 4, and unlimited makes 4 my smallest number. So that would be 29.05 meters per second. And that means every second you travel 29.05 meters, which is a little bit more than 100 feet. So when you're going down the freeway at 65 miles an hour and you look at your cell phone for a second, you've missed 100 feet. Can you read a text message in a second? 3 seconds. 3 seconds you've traveled a football field without knowing what's coming at you, without looking at the road. See why distracted driving is a problem? That's one of the reasons. One of the reasons is physical limitations. Your eyes are off the road so you don't see what's in front of you. The other is brain limitations. If you're thinking about conversation, which our brain is really good at, you're not thinking about driving. So the conversation thought takes over your brain and you're driving to a wall. Okay. We'll talk more about density soon. But for right now, I needed something with 2 units. So I'm picking this one because it had 2 units. Density of lead is 11.4 grams per milliliter. What is this in pounds per quart? So if I had a milliliter of lead, it would weigh 11.4 grams. If I had a quart of lead, how much would it weigh? That would be pounds per quart. Now I give you a couple of other factoids. I've got 454 grams is 1 pound, and a liter is 1.06 quarts. So I start off by writing down what they gave me, 11.4 grams over milliliters. Turn it vertical so you think top and bottom. Now I've got some conversion factors. What unit do I want to get rid of? Well, both of them. When I'm done, I don't want grams on top, I want pounds on top. When I'm done, I don't want milliliters on the bottom, I want quarts on the bottom. So I have to turn the top from grams to pounds. I've got to turn the bottom from milliliters to quarts. And I can do both of those. Okay? I just have to do them separately. And it doesn't matter which one you start with. You just got to do them, make sure you do them both. So what do you want to get rid of? Grams or milliliters? Grams. I usually do the top first because I'm used to doing the top, but you don't have to. So grams has to go on the bottom to cancel out. What can I turn grams into? Because I got this, I can turn grams into pounds. And the numbers are 1 pound is 454 grams. And the grams have canceled out. Now my top looks the way I want it to, so I leave it alone. What unit do I want to get rid of? Milliliters. Where's it got to go to cancel out? On the top. Okay. I should plan this out. Milliliters, how am I going to get, so on the bottom, what do I got to change that to? Because if I change it to liters, then I'll be able to take the liters and change them to quarts. Because I know liters and quarts. So milliliters I can change to liters, which is bigger. The liter of the milliliter. Liter, so liter gets the 1, the milli gets the 1,000. And milliliters have canceled out. Now what unit do I want to get rid of? Liters, where's it got to go? On the top. And what can I turn liters into? I can turn liters into quarts. And the numbers are 1 liter is 1.06 quarts. I just copy the numbers down. And then I push buttons. 11.4 divided by 454 times 1,000 divided by 1.06 equals. My calculator gives me 23.68880392. Way more digits than I can justify. Yeah. So let's think about sig figs. 11.4 grams per milliliter. Is that a definition? That's something you measure. Can you define how dense something's going to be? Here's a piece of wood. Tell me how make it this dense. I can't do that. Can't define a density. So this has 3 sig figs on the 11.4. Pounds and grams, same system or different system? Different. We use grams every day. Do we use grams every day? When you weigh yourself, do you weigh yourself in grams? Or kilograms? Now you step on the scale and you do it in pounds and ounces, right? So the things we use, pounds and ounces, are a different system than the metric system. So this is different, so that means this has 3 sig figs because of the 454. Milliliters and liters, same system or different? Same, so that is unlimited. Liters and quarts, same or different? Different, so I take the most. 3. So I've got 3 sig figs, unlimited, and 3. How many can my answer have? 3, so that is 23.7 units I got left are pounds over quarts. Everybody see the huge differences we're doing today than what you did with the metric system? Everybody see why I was so insistent that you do more than one metric, that you don't try to do prefix to prefix, that you chain the conversion factors together, because I knew we were going to start putting conversion factors together. Okay? So the way to get good at this is to ask your neighbor. No, that's not it. Write the answers down in your calculator. No, that's not how you get good at it. The way to get good at this is to practice. So, and just so everybody's clear, on every math assignment from now on, from this point forward, ever since we learned how to do it, the instructions are, show your work, include the units. Include the units means everywhere you're supposed to have a unit, you should write a unit in. Okay? And round to the right sig figs. We don't just write the units at the end and pretend they worked out. Because units are our friends. They set up the problem. Hopefully you're seeing that now. I would not have wanted to do this by thinking. Notice how much thought we put into this. Put a lot of thought into figuring out how heavy that was going to be. How you're going to go about solving that problem. Nah, we just did what it said. Hey, make sure you got two sides. I think I got the master here. Show your work, include the units, use the correct sig figs.